All right, lesson 4, solving rational equations. So we're going to revisit an old method that you probably used in geometry for sure, and definitely in Algebra 1. But we're going to start cross multiplying. So if I get an equation that looks something like this, what I'm going to do is I'm going to cross multiply. So I'm going to multiply these two together and these two together. And then I'm going to solve for x. So this is going to be 3 times 4x plus 5 equals 9 times x plus 1. 12x plus 15 equals 9x plus 9. Subtract 9x. 3x plus 15 equals 9. Subtract 15. 3x equals negative 6. And when you divide by 3 on both sides, you get x equals negative 2. So cross multiplying, again, very effective when you have an x on both sides of your equal signs. Doesn't necessarily have to be that way. There's another example. If we had something like this, 5 over x plus 7 over 4 equals negative 9 over x. I would say I'm going to multiply by the LCD, or again, what I'm going to do is I'm going to try to get everything to have the same denominator. So again, if that was the case, I would multiply this whole thing by 4x, and I would multiply this whole thing by 4x. So therefore, I'm going to end up getting (20x over x) plus 28x over 4, which we'll simplify, equals negative 36x over x. Again, we like simplifying. This goes away. 28 divided by 4 is 7. So this is just 20 plus 7x equals, and x divided by x cancels out. Now I get my x's on one side, all my other numbers on the other. Divide by 7, and x equals negative 8. If I wanted to solve a rational equation with 2 solutions, so maybe we had something like this. Let's see here. X minus 5 equals 3x. I'm going to start by, again, figuring out what do I need to multiply by so that I get the same denominator on both sides. And that's going to be x times x minus 5. And same thing over here, x times x minus 5. I'm going to put it over 1 just so I can keep it straight. But as I simplify this, I find out that I'm going to end up getting, okay, on the left or on the right side here, that x in the denominator is going to cancel out. So I'm just left with 3x minus 5. And over here, I see that my x minus 5 and x minus 5 cancel out. So I'm just left with x times x minus 5 minus 8x. Let me just clarify. So again, this is going into this term, and it's going into this term. So when I said it canceled out, it only cancels out on this second term because it's on the top and the bottom. So again, that's how I ended up with getting this x minus 5, because I did 1 times x minus 5, and then 8 times x is how I got 8x there. So if we're simplifying, x squared minus 5x minus 8x equals 3x minus 15. X squared minus 13x equals 3x minus 15. Let's subtract 3x and add 15 on both sides. So we are left with x squared minus 10x plus 15 equals 0. I do my factoring x, what multiplies to 15 but adds to get negative 10. Oh wait, I must have, let's see here. Negative 13 minus 3 is negative 16, Mr. Larson. So it adds to get negative 16. That's negative 15 and negative 1. So x minus 1, x minus 15, which means x equals 1 or x equals 15. In order to factor it, remember you have to have it equal to 0, which is why I subtracted and got everything on the left side so that I could factor it. Our last example, we're going to check for extraneous solutions. We'll talk about what that means. So let's say that we have 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. So I'm going to say that the least common denominator, the LCD, is x plus 3, x minus 3. So I'm going to multiply the left side and the right side by this LCD. So the left side, I'm going to have 6 over x minus 3, and we're going to multiply it by x plus 3 and x minus 3. And that's going to equal, and again, I have to do this to both terms, so it's going to be x plus 3, x minus 3, and then this first term, 8x squared over x squared minus 9. And then that's going to subtract, and I'm going to have x plus 3, x minus 3, and then 4x over x plus 3 on the bottom. Now let's look to see if we can simplify anything. So on the left side, I see I have x minus 3 and x minus 3, which means I'm just left with this. Excuse me. The bottom, x squared minus 9, that can be rewritten as x minus 3, x plus 3. So I can actually cancel out both of those. And I'm just left with 8x squared. And then over here, I have x plus 3, x plus 3. So I'm going to subtract from x minus 3 times 4x. 6x plus 18 equals 8x squared. If we multiply this, we get x squared minus 3x, or let's see here, x squared plus 4x minus 3x minus, well, that's it. Oh, x, so it'd be 4x squared. X times 4x squared is 4x squared, sorry. And then negative 3 times x is negative 12x. So, and then this negative gets applied to the whole thing. So minus 4x squared, and that negative times a negative turns into plus 12x. So now again, let's just get everything together. Subtract 6x, subtract 18. Oops. All right, so my 6x is going to be over here, and subtract 18. And these are actually like terms. So we're going to have 0 left over here. 8 minus 4 is 4, plus 6x minus 18. I believe we can factor out a 2 from each of these. So if we factored out a 2, x squared, 2x squared plus 3x minus 9. We could divide that 2 on both sides. Again, 0 divided by 2 isn't going to do anything. So 0 equals 2x squared plus 3x minus 9. And I can think about, well, the only way to multiply to get 2 is 2 times 1. So I have 2x and 1x. And then they need to multiply to get negative 9, but add to get positive 3. So if I do it like that, I'm going to get an answer of 2x minus 3 equals 0, and x plus 3 equals 0, 2x equals 3, x equals 3 halves, or x equals negative 3.